Hello, good morning, everyone. Today I will give a representation for the new generation AHU kit D series. My presentation have totally 5 parts, and the first part we will give an introduction for the product. As you note, normally we can use our VRF outdoor unit to connect to the normally, or we call the standard the indoor unit. But the AHU normally connect to the chiller. But we had a special HU we call the DXHU. This means the director special HUs. This kind of HUs can connect to the VRF via the AHU kit. This is a simple picture to show the diagrams. We can get a sample for the V6 art, our 3-pipe VRF. This our MX box, but this one is not matter. If our unit is the heat pump or the cooling only this MX box. But the main part is the HU kit and the DHHUs. Through our HU kit, we can allow to connect the normally the indoor unit and the DXHU together. And for the wireless controller, we can have the you can select use the MyDell controller. This controller was built in the HU kit. You can also select the third part DDC controller. This DDC controller you should buy in the local by yourself. From many years, we had so many generation the kit, so we can get a simple the reviews. Now the A series was the phase out, is unavailable, but the B series is still available. But we don't suggest you to the place order for this series, as we had the D series. You can see the D series will have the more function compared with the older generation. The special one is the flash air or the return air mode control. As our D generation can compatible with the V6. Also, we can compatible with the V4 Plus. So we recommend you to place the D series. Also, the B series and the C series will phase out in this year. So we should pay more attention in the D series. For the kit, we can see they had made totally the 4-part components. The first part is they will have the built-in the PCB and the EXV and some sensors and one controller. This main 4 parts made on the HU kit. We can get a consensus. Okay. We can make a consensus. One HU kit after one or more DXHU, we can think about this was equipped to the VRF normally the indoor unit. So this is the why we need HU kit, as the HU kit don't have the PCB and ESV or some sensors. So we can think about this. The kit just like the electric box of the normally indoor unit. We just divide the indoor unit for the 2 parts. One part is the electric box, and HU part just like the coil the EH coil. So this value can easily understand why we can say the AHU kit at the AHU as the VRF indoor unit. And last year we had totally the three model had four models for the D series, and the capacity range is from the 2.2 kilowatt to the to the 5.6 kilowatt. And the last year we had launched the two new models, the 0.4D and the 0.5D. Then allow us the maximum capacity up to the 117 kilowatt in one the single kit. So we also give some the combination tables. We recommend you to use the maximum the capacity is used to the 0.5D kit can meet the maximum the capacity is the 314 kilowatt. May you have a question? Why their right can the maximum the four number of the combination, but the recommended combination table only the 2 AHU kit. That is the and normally in the VRF industries, we didn't have so much bigger the outdoor unit systems. So in one refrigerant systems, the indoor size capacity can reach up to the 314 kilowatt. Is full covering the outdoor units, the range. This is why we only say two kit combinations. But normally we can use the master for the numbers of combinations. And the flexible and extensible the function. The AHU kit, the capacity is can from the single is can the 2.2 kilowatt to the 5 kilowatt, and for the combination, the capacity can up to the 314 kilowatt. Just the message before. This is the this radio. The combination radio is for the heat pump, VRF, or the cooling only systems. And for the 3-pipe, the VRF systems, we can only allow AHU capacity and mass mount to the 12 kilowatt. This one is very important. Also, thanks to the flexible and wide capacity range, our AHU kit can be paired with the more AHU mode. We can also use the maximum 4 AHU kit to connect one bigger AHU. And for the AHU part, when the capacity is up to the 14.6 kilowatt, we should use the 2 or more AHU kits. For the capacity less than the 14.6 kilowatt, we can use the only one AHU kit. And for this series, we had new features is for the return air temperature control or the supply air control. We can provide 2 modes to control the temperature. This function should be asked for the AHU kit should be a flash air unit. To be asked AHU should be a flash air unit. If not, we didn't have the flash air. For the return air, the control just same as the normally the HU. For the flash air, the controller should be asked for this HU should be the flash. And the second part is the selection and the design. Firstly, we should know the some rules of the VRF systems when they connect to the AHU kit. Firstly, we will add to the heat pump and the cooling unlink. First, when the VRF directly connect to the VRF outdoor unit, and this system and unlink had the AHU, we can have the maximum, the combination ratio is the 100%, and the minimum capacity rate should be the 50%. This is the big difference compared with the normal VRF system, the combination ratios. And when we had AHU and the normal indoor unit, the maximum, the combination rate of the system is the same, is the range from the 50% to the 100%. But AHU capacity should be not exceed the 15% of the outdoor unit. This is the one more the strict rules when you have the normal indoor unit in the same refrigeration systems. This application is for the return air AHU. When the AHU is a flash unit, or you select the flash when you use the flash air controls. The first one, the combination rate, when they only have the DXHU, this is the same. But when you use the flash air controls, the flash air capacity should not exceed the 30% of the outdoor unit capacity. This is the one more the strict rules when you use the flash air control. And for the 3-pi systems, currently we have the V6Rs. We didn't allow the heat recovery is the V6R directly connect to the AHU, DXKHU. We don't allow the V6R connect to the DXAHU directly. We didn't allow this. If you want to connect the one AHU to the 3-pi units, you should connect the normally indoor unit in this systems. The totally of the combination rate of the system is the same range of the 50% to the 100%. And the ratio of the HU should be less the 15% of the totally the capacity of the outdoor units. This is for the return air controls. And for the flash air control, we didn't allow any directly controlled AHU to the V6R. This same as the return air controls. One more stricter rules for the flash air HU connect to the V6R. This is the flash air HU capacity can exist to the 30% of the outdoor unit capacities. And for the mini VRF outdoor units, only the return air temperature control can be selected. It means when you connect the DXHU to the mini VRF, you can use the flash air control modes. Maybe you have question why we can use the flash air control mode in the VRF systems. This is the reason is the mini VRF the system is too small. Normally the flash air is really had a big difference temperature with the return air. So when the flash air is come from the outside, they will cause the outdoor unit should be the output much more the capacity. But our VRF is normally the smaller capacity. So when the flash air come from outside, the VRF will be have the over frequency. So maybe some errors. Also, the system is not very reliable. So we didn't allow you use the mini VRF to connect to the flash air mode of the AHU. And for the HU selection, the rules we normally according to the complexity tables. Normally we can according to the AHU the capacity to select the AHU kit, just like this. Oh, sorry. So like if your AHU kit is the 8 kilowatt and the air value is less than the 1000 or not is equal to the 1300, you can select the 00D kit and put the selecting cooling capacity dial switch to the 2.5. So if you had if the capacity is the 8 or less 8, but the air value is over the 1300, you can select this one. When we select the AHU and setting the cooling capacity, we should follow the range of the air value and the HU capacities. This toolbar should be the follows. And the capacity should be the radial condition is in the 27 degrees drop box and 19 degrees for the WAM box here. And the radial conduction of the evaporation, the temperature is the 6 degrees and the superheat is the 5 degrees. So now we can already measure the maximum capacity up to the 314 kilowatt, and we can allow the maximum to connect to maximum the 6 kit to connect one HU kit here. So we had a symbol. This is the V6R 3 pi seconds. So we can see the outdoor unit is the 15.6 kilowatt, and we had AHU, BSHU. The capacity is the 16.5 kilowatt, and this HU kit capacity is less than 28 kilowatt. Sorry. Is less than 28 kilowatt. This rule is correct. And totally the indoor unit capacity is about 38 kilowatt. And the HU kit is the less than 15% of the totally indoor unit capacity. This rule is correct. So this section is correct. You can see that, and also the combination ratio of this system is the less than 100%. Is here. If this AHU use the flash air mode control, this also correct as the less the 14% occupied in this second. For the heat pump unit, we had normally we had two connection modes. This is the mode 8. This is the one HU kit can connect to the one kit. This is the very normal way to connect to the HUs. And there should be the one thing to be noticed is the HU kit and the HU. This distance between them should be less than 8 meters. You can see the diagram here. Here is the kit. Here is the HU. So the A2 should be less or equal to 8 meters. The B2, B3, or the C2 is the same. This is a very important principles. And the mode B is the one HU kit connect to the more than one kit. But the standard principle should be the same. Just like this, the B2 or the C2 and the A2 plus the L4 should be less than 8 meters. Should be less than 8 meters. And when we use the more than one kit connect to the one AHUs, we should select one kit as the master AHU kit, and after the set to the select AHU kit. This is the very important part. As when the next part of weldings, as the master the AHU kit will have a different the sensor the place between the slave kit. And this part we should pay more attention is the AHU kit. The distance between the AHU kit and AHU should be less than 8 meters. And the V6R. And the V6R, the maximum capacity is the 28 kilowatt of HU. This we had the measure several times because this is very important. As the AHU can be is to the 28 kilowatt. So normally we can only use kit. We are simple case to connect the DHHU is enough. So the next part is the wiring diagrams. Okay, this is the made PCB for the kit. We can see here this part is the XYE port. And this port is for the older wireless controller, just the 12 volt or the 10 volt wireless controller KJR. This is the very old. They had the three terminals wireless controller. And here is for the water pump. Maybe this part, this picture didn't can seem very clear for the each terminal numbers. We just get a simple recognize for the each port. But on off or the cold and heat and fan, you can select this. The data we will have the more detailed for the each port to the instructions. We just go through the function in the main PCB points. The 0 to 10 volt controlled. And here is for the sensors. The sensor we had the T1, T2, T2A, or T2B, T2B, and the TA, flash air controlled. T1 is for the latent air controlled. And this report is for the EEV. And this white port is for the swing motor. But I think this port is normally useful. It didn't use this port. And other is the AHU heaters for the CN12. CN12 is for the AHU heater. And the alarm or the water pump. This the water pump is the power. The power. And here the water pump is for the control the signal. Here is for the signal. Control signal. And here is for the power supply for the water pumps. And here this 4 port is for the fan power supply. And this point is for the power supply for the main PCB. Okay, then we had the point descriptions. Normally we had used the PQ. PQ is the communication with the outdoor units. And the X1, X2 is connect to the wireless control, like the 186 KGI 86. And the D1, D2 you connect to the wireless controller KGR 120G. And the last this point is all the dot contact or the dot contact point on off and the cold heat fan alarm or the default alert or the dot contacts. Here we have some the recommend close the section for the while. For the power supply and the water pump, the wiring connections. Normally, for the power supply, we connect to the LN, CN2 LNs. And for the fan control, is for the single fan. For the single fan, we can connect to the HML to have the high spring and the middle fan or the low fan with the three fan speeds. And the pump we connect to the CM1. And should be note here it had the light, the specification for the each kit model. It's the 2.1 millimeter square, the square for the 002 this two kits, and the 5 millimeters 5.0 square millimeter for the 02 and the 03 deed mode, and relate the maximum current for the 00 and the 01D is the 3.5 amps. That is the master current. If the current over these values, we should connect to the relate. We should have a relate. We should use a relate to like a bridge to control. If the current is over the maximum currents. And for the fan controls, we had a two-way to control the fan speeds. We can directly connect to the CN3 and the CN4 to achieve the three fan speeds. So three fan speeds. The height, the middle, the low to have the three fan speeds. We can also use the CN 16 ones to control the fan speed via the 0 to the 10 volt output. But for the CN 61 point, use this. If you use this point connect to control the fan speeds, here should be the rules should be the follows. This is the ENC2 and the ENC3 and the ENC4 should be had this relates. The ENC4 should be plus bigger than the ENC3, and ENC3 should be the bigger than the ENC2. And normally for the 0 to 10 volt controlled, the 2 volt is for the lower speed. This is for the low speed. And the 7 volt is the middle speed. And the 10 volt is for the higher speed controls. You can also change the this value for the each speed, but should be follow these rules. You can select the high speed in the 10 volt. Oh, sorry. Here I can only set the 10 volt. The high should be set in the 10 volt, but the middle you can set in the from 4 to 9 volt. And lower you can set the 1 to 3 volt. This is for the 0 to 10 volt output control. And for the CN3 and the CN4, you can connect directly for the relay the fan speeds. Okay, this is the we measured before the maximum currents. The 00 and the 01, the maximum current is the 3.5 amps, and the 02 and the 03 kits the maximum current is the 15 amps. If the circle over this the maximum currents, we should use the relay. We should use a relay. And then connect to the fan terminals of the main block. And for the three-phase motors, we can only set the high speed. And the dialog switch, the 1-2 should be selected off. That's off. So if your AHU select the three-phase motors, there are only one speed available, just the high speeds. And for the communication cables, the PQE is connected to the other indoor units and with the outdoor units. And the D1, D2 is the connect to the group control, WDC 110G. And the X1, X2, you can connect to the standard. The standard is Mr. built-in the AHU kit. The wire control is the WDC 186. And the XY or XY, they will connect with the master AHU kit and the slate AHU kit. Okay, this is the base the communication cables connections. And this part is the connection for the communication with the third-party DC, the jog connect. If you use the third-party controller, you should connect to the CN17 and the CN18, these two terminals. And also there will have some setting in the my PC boards. We will show later. Now we can just show the cables connections. If we use the third-party DCs, we should connect to the controlled mode with this diagrams. On off, we will connect to the CN9, and the cooling mode, heat mode, or the fan mode should be connected to CN32. And the different 1 to 10 volt control should be connected to the CN61. Just the method before, the CN61 is for the fans, for the fan controls. And this one is for the, you can select the temperature controls or the capacity controls via the 0 to the 10 volt inputs. Later we will have the details for this part. Okay, this is the simple schedules for the SIGNET wiring. For the outdoor size, we have the standard control to the central controller via the XYEs. This is the same with the normally the VRF systems. And for the between the outdoor unit and the indoor unit. The indoor unit is include the AHU. This is the same the normally VRF systems. they can, via the PQE, connect. And between the different indoor units, and also include the different HU kits, we also use the PQ to connect them with the hand by hand, And if you select the third part controller, you can also sit in the AHU kit. In this point, connect the CN17 and the CN18 of the AHU kit. And for the sensors, we just talk about these pictures. We can see here had the 3 kits connect to one AHU. So normally we place the T1, T2, T2A, T2B, T2 or the sensor in one HU via the master HU. The master HU, all the sensors will place in the HU. And also, you can place the slave, the T2, T2A, T2B to the HU, but didn't need to connect the TA, T2, T1, TA to the AHU coils for the select HU. The T1 and the TA only connect to the HU from the master HU kit. Okay. The preparation for the installation for the HU kit. Here is the very important things to be noticed is we can installation the HU kit in the vertical, should be vertical. As the ESV placed in the kit is the vertical, so we should keep the kit installed in the vertical ways. If you think the HU kit installed in the vertical kit is not very convenient, you want to place the kit in the horizontal. You can divide the kit and the EXV parts separated. You can take the EXV part from the kit and install the EXV parts vertical. And then you can leave the kit horizontal. But when you take the EXV out of the kit, the distance between the kit box and the EXV part should be less than 5 meters. Should be 5 meters. The kit box between the EXV parts should be less than 5 meters. Okay, this part is for the temperature sensors place. The T1, TA for the temperature controls, they will use the black metals, and the T2A, T2B is with the copper colors. is the metals. And here we had the find its extension well in the accessories. And the TA is the long temperature sensors. We can also call it the return air control sensors. And the T2A is the evaporating inlet temperature sensor, and the T2 is the evaporator middle temperature sensors, and the T2B is the evaporator outlet temperature sensors, and the TA is the circular air temperature sensor. We also call it flash air sensors for flash air. And here should be placed the outlet, the temperature sensors is T2B, and in the distributor will place the T2A is the refrigerant inlet. The refrigerant inlet port we will place the T2A. In the circle, the Cooper cycle, we place the T2. This is the middle, the temperature sensors. In the half the cycle Cooper. And for the T1, TA, if you select the return air controls, you can put the TA in the return air port. If the select the flash air control, or we call the circular air controls, you should put the TA sensor in the circular air. You can also put all the sensors in their place and select use the TA control or the T1 control or TA control select by the wire control or the dial switch. You can place all the sensors in the AHU directly, and then you can select by the dial switch. Okay, for the temperature sensors, as we had the different connection with the between the AHU and the AHU kits, so we will introduce the main two modes, the details. And the first one is the multiple AHU kit connect to one AHU. And just the method before the first lead, we should note we should set a master. We should set a master AHU firstly, and after AHU kit should be the sit in the slave. Then we only need to place the sensor of the master kit. Just like, and we should put the SW5-2 off. So we can say we set the kit 1 is the master. The kit 1 is the master, and the kit 2 and the kit 3 is the slave. So in this situation, we only need to connect T1, T2, T2A, TA, T2B sensors to the master kit. Okay, this is the mode 8. For the mode B, here it so had one AHU had multiple core. Just like AHU had uh, one had 2 cores. For this pass, if one AHU had multiple cores, we should select SW5-2 off on. And set a master kit. And the other is the slave kit. So in these situations, each kit should be placed the T2, T2A, and the T2B in the related coil, just like the kit 1 is the master kit. So the kit 1, the T2, T2A, and the T2B should be placed in the coil 1s. And the slave kit 2 also should be the place the T2, T2A, and the T2B to the coil 2. They need to place the T2, T2A, T2B separately in the corresponding the coils. And then the T1 or the T8 sensors only required for the master kits, and the T1s only come from the master kit. TA or the T1, TA or the T1 only come from the master kit. But for the each coil of the AHU should be placed the T2A, T2B, and the T2 from the corresponding kit. Okay, here have a more clear picture to show. And for the mode 8, here is the multiple kit connect with the one HU, and the HU only had one coil. So we can only place the T1, T2, T2A, T2B, and the TA to the HU from the master kit. And the slave kit didn't need to place any sensors. We just need to connect the signal the communication well between the master and slave kit via the SYE. Sorry, here should be something wrong. Here should be the PQ. Here should be the PQ. And for the master tooth, here is so the when one HU had 2 coils, so we need to use the 2 kits to connect to the each coil, and each HU should be placed the T2, T2A to each coil separately, just like the master kit place the T2, T2A, T2B to the coil 1, and the later HU kit place the T2, T2A, T2B to the coil 2, and then the TA and the TA was the T1 unlink from the master kit to place the coils. If they had two coils, the T1 should be placed in the return here, the return air port, and the TA should be placed the supply air port. Here is the two methods for the temperature sensor installations. And the next part is the applications in the signal. Okay, if we select the return air control, we should select SW 4-1 to 0 in the my PCB. When you select the SW 4-1 to 0, it means that we have the select the return air temperature controls. So the T1 sensor should be placed in the return air ports. And for the flash air controls, we should put the SW 4-1 to 1. And then the TA should be placed in the supply air. Just our method before. You can place the T1 and the TA in the AHU kits when you in installation. You can put the T1 and the TA and the same time in one AHU. It doesn't matter, but you should select the control the ways via the SW 4-1. If you select the flash air controls, the T1 you can place here, but the T1 didn't work. Just the TA sensors can work. Okay, the last part is for the controller selections. As with the method before, you can select the you can select the standard media controller, as we had built-in the KJR 186 DC in the kit. This one is the standard built-in the kit. So we can select download the SW 4-3 and the SW 4-4 to choose the different control mode. If the SW 4-3 and the SW 4-4 all in the 0, this means that you select the media control. So if you put the SW 4-3 and SW 4-4 to the 0-1 or 1-0, this means that you have to select the SEPA DDC controller. And if you select the 0, 1. This is means that you select the 0 to 10 voltage capacity controls. And for the 1, 0, this means the 0 to 10 volt the temperature controls. Whatever you select which the capacity or the temperature controls, you should select SW4-3 and SW4-4 not in the 0, 0. Okay, let's talk about these parts one by one. Okay, this is the wiring, the diagram, and the temperature controls. This thing, the media control is built in the AHU kits. This is for the 0 point, from the 0 point to the 10 volt the controller. Okay, for the 0 to 10 volt the temperature control, as we have the measure before, we can select SW4-3 and 4-4. They will turn to the 0, 1. That is means that you had select the DC control, and with the 0 to 10 voltage temperature controls. This is show the relationships. Here should be the one more thing should be the notice, just like this. The data range will have a maximum value and a minimum value and a maximum value. Only the value between the max, the minimum and the maximum, only can the controller can respond. Just like if you put the wolf for the just like the 1.2, this 1.2 is out of the range for the standard one, and also out of the range of the 1.4. So if you put this the 1.2 volt, the controller didn't have any response. So should be noticed this. You select the voltage should be between the data range. If out of the range, the controller didn't have any response. The same rule is also same as the temperature controls of the flash controls. Is the same. The input the data should be in the range of the minimum and the maximum for each value. And for the capacity controls, here is the table for the capacity controls for the different voltage from the 0 to 10 voltage. For this, the capacity settings, you can find there was not any gap between the volt. It's the big difference with the temperature controls. In the temperature controls, they will have some gap between the each standard values. So if you input the value in the gap, the controller will have not any response. But in this capacity controls, they don't have any gap. They all had a continued control, just like the 0.5 should be the less or the equal, and less than the 1.5 volt. But from 2, the 1.5 had the equal to. If you have equal to, this is the continuous. Is no any gap for the control signal. This is the big difference with the temperature control and the capacity control. And whatever you select the MIDIA controller or the DDC controller, the MIDIA controller should be used, as you should need to select some function, or just like the base. The base is for the addressing. You should select you should setting the addressing for the AHU. So the MIDIA wire controller or the MIDIA wire controller should be used. Here you can see here. The MIDIA wire controller can be used to set the addressing and require the parameters. Wherever you select the MIDIA or the third-party DC, the MIDIA wire controller should be used. Here is the some signal from the DDC. That is the very simple. When you connect to the DDC, you just follow this table and pay attention to the different signals. Just light off. You should means the close, means the remote shutdown, and the disconnect is means the remote turn off. Maybe this logical is had a little different with the other brand. That should be pay attention to. For the other brand, I had seen is the disconnect is mean the off, and the close is means the on. So for the MIDIA, the close is mean the remote shutdown, and the disconnect is mean the remote turn off. There should be no this big difference point. And the cooling mode and the heating mode and or the fan stat or the connect to the corresponding points. And the default alarm is all the connect via the jockey contact. Okay, the next part is also the most important part is for the address settings. If the outdoor unit is the old generation, the old generation is Mr. V4 Plus and the V6, the V5X outdoor units. Especially for the V4 Plus, as there have no any auto addressing, as this unit know the auto addressing function. So we should get the addressing to the AHU by the manually. And you can see here the ENC1 is means the address. And you can see it when you select the capacity in the 3 horsepower, It means that they will have occupied one address. We call this is the array address. And if you select from the EF here, in the zero, if you select the capacity in the EOF, that is means this kit will occupy two addressing. Will occupy the two addressing. And for the 0 to D is one addressing for each AHU. And if the SW fall down to select to the ones, when you select ENC1 from the 0, from the 0 to the in the 0 to the D, we will occupy. We will have also occupy the two addressing. We occupy the two addressing for one AHU kit. Is here. Sorry, is here. And if you select the last suite capacities, here we occupied 4 addressing for each AHU kit. So we should let me review it again. When the SW4-2 select 0 and the ENC1 selected from the 0 to D, each kit will occupy the one addressing. And the SW2-2 kit in the 0 and the ENC1 select E or F. This AHU kit will occupy two addressing. And the SW4-2 turn to the 1. And ENC1 select the 0 or 1. This kit will occupy the two addressing. And the SW4-2 select to 1 and ENC1 select to 2, 3, 4. This 3 capacity, this kit should be occupied 4 addressing. So we can imagine this if we had the 3 kit, or we had the 4 kits. We had the 4 kits. One kit in this region. Here we occupy 1 addressing. This is for the first AHU kit. We occupy 1 kit. And I had the second kit. Select E. That means the second AHU kit. We occupied 2 addressing. And at the third AHU kit, select here. That means the third one AHU kit. We occupy the 2 addressing, and the fourth AHU kit select here. So they will occupy 4 addressing. If we select the first one kit is the master AHU kit, and I get the master AHU kit is the address. It is just like we can from the 2. Okay, we can get the 2 address, get a number 2, get a number 2 address for the master AHU kit, and the master kit will occupy 1 addressing. So the number 2 is for the AHU kit 1, and AHU kit 2 is a slave AHU kit, and they will be the follow the master. So the addressing will from 2 as the second AHU kit occupy the 2 addressing. So this AHU kit will occupy the 2 and 3. 2 and 3 number will occupy by the second AHU kit. And the same way for the third AHU kit. They will follow the address will follow the second one. So they start from the number 4, and he occupies the 2 addressing. So the number 4 and the number 5 was occupied by the third AHU kit. So the same way for the fourth AHU kit, they will follow the 6 as he occupied the 4 addressing. So we will occupy the 6, 7, 8, 9. This 4 number. So you can see there will be had one. They will have 1, 2, 3, 4, 5, 6, 7, 8, 9. They will occupy totally the 8 at the number at the addressing. So you check the wireless controller. You will find there so 8 in the unit. But actually you only had the 4 kit. But the wireless controller will show that you had the 8 in the unit. As the wireless controller thing, each number will have a 1 in the unit. So this is the very important part. So remember, set the right address for the each AHU kit. This is for the old generation VRF, as this VRF didn't have the out of addressing function. So the addressing setting of the AHU kit should be has some complex. Here is another samples. Currently, we have get a sample in this page, and here is another samples. Also have the 4 kits, and for the first one, and the first one, they will occupy the 4 number address, and the slate 2 and the slate 3 AHU kit also had occupied the 4 addressing, and the last one had occupied the 2 addressing. So totally they occupy the 14 addressing. So when you setting addressing via the wireless controller, you should follow these rules. Follow these rules. Also, you will see there will be had the 14 outdoor units via the CCM or the wireless controller. They will be considered as the 14 indoor units addressed from the 5 to 15. But actually, they only totally the 4 kids. But for the BMS or the central controller or the wireless controller, they will be these 4 kids will be the considered as the 14 indoor units, as they all occupy the 14 addressing. This is for the V5 Plus and the V5X for the menu settings. And for the V6 plan port, we normally use the auto addressing. So there is a big difference. We can select the auto addressing function in the outdoor unit, and then we didn't need to calculate the AHU kit will occupy how many addressing. And for the wireless controller and the CCM or the central controller, they will can only set the real AHU kit, the real number of AHU kit. As the here had the same 4 AHU kits. For the V6 Plus and the V5X, they will show in the CCM or the wireless controller have the 14 indoor units. But in the V6, in the V6 and the V6 the wireless controller, for the controller or the CCM or the BMS, here is show the real number of the kids. They will have the, so here should be the 4, sorry. This the 5 is the start addressing. The outdoor unit we will show the number of the AHU kids. This is the big difference compared with the old generation VRF. So when we had some seconds, we should notice the big difference between the old generation and the new generation VRF. The main difference is the controller show the number of the indoor units and also the adjusting the settings. Okay, this is all my presentation for the D-Series AHU kits.